Okay, so when is the particle at rest? And by at rest, we mean it's not moving or it's pausing. In other words, if it's not moving, its position is constant. The particle is always 2 meters from the origin, right? So if position is constant, then what must be true? Then its rate of change must be 0. Its derivative must be 0. Velocity, which is the derivative of position, must be 0. Okay, so all we have to do is we have to set the velocity function equal to 0. And my velocity function is from right here. We got it already in 1a. My velocity function is 3t squared minus 24t plus 36, and I'm going to set it equal to 0 and solve for t. Find the moments in time when the velocity is 0. Find the moments in time when my position is constant. So I see a GCF here of 3. 3 times t squared minus 8t would give me minus 24t plus 12. 3 times 12 is 36. I can go ahead and divide both sides by 3 if I want to. Let's go ahead and factor two things that multiply together to give me 12 and add up to minus 8, minus 2, and minus 6. So this happens setting each one of those equal to 0 when t equals 2 or when t equals 6. The velocity is 0 when the position is constant. And in this case, it's when at t equals 2 seconds and t equals 6 seconds. Excellent. So now what I want us to do is I want to investigate this graph that I've put together for us on Desmos, just to get some more intuition. So here we have the particle, and this is the linear motion that we're trying to describe. The particle is going up, and then it's coming down. You know, what's the position, velocity, and acceleration at any given moment in time? Is that particle speeding up or slowing down? Here it looks like it's speeding up. Okay, so here's my position function, that cubic. Notice that the y-coordinate of the position function is how high off the ground the particle is. My velocity is the derivative of my position function. The slope of the tangent line to the velocity, or to the position function right here, that green slope, is the y-coordinate on the derivative of position. It is the y-coordinate on velocity. If we just look at those two together, let's take this off. Notice, boom, boom. Notice that when my position is increasing, velocity is positive. Velocity is above the time axis here. Now position is decreasing between 2 and 6, and velocity is negative. The green function is below the time axis. And then here again, my position is increasing and velocity is positive. We're above the time axis there. Acceleration is the derivative of position. Is the derivative of velocity. Let's turn, I was thinking about turning velocity off. On, I mean. Notice that when velocity, the green function, is decreasing between 0 and 4 seconds, my acceleration, the derivative of velocity, is negative. Here we are below the t-axis. And now my velocity is increasing and my acceleration is positive. We're above the t-axis. I encourage you to go ahead and play around with this, but for right now, let's move on to our next video.